Okay, we want to talk about transforming a point. Now, the point 2,4, if we shift the point 2,4 2 units vertically, what are the coordinates of the new point? Well, first of all, and I understand this, I was kind of late getting the idea of horizontal and vertical. You know, played a lot of football when I was in high school, not on the team, but Sandlot was pretty good players. I was just mediocre. You know, in playing football, you try to stay vertical. Sometimes you end up horizontal, okay? I probably ended up horizontal more than most. Didn't have the greatest balance. Okay, so you got vertical, you got horizontal. To shift the point 2 units vertically means you move it upward 2 units, which means you're going to go from 2,4, you're going to go up 2 units and end up at the point 2,6. So, here's your answer. Now to shift 2,4, negative 3 units horizontally, what happens? Well, horizontal direction is this, so the negative horizontal direction is this. So you're going to shift 2,4 3 units to the left. It'll be a negative 3 unit movement in the horizontal direction. And of course, if you do that, you end up, well, your x value is 2 here, you go over to 1, 0, and negative 1. So x ends up at negative 1. Y doesn't change. Just like when you move vertically, x didn't change. But that's 2 possible transformations, a vertical shift and a horizontal shift. Okay, these are vertical and horizontal shifts. You can do this with the basic points on any of the basic graphs and transform the graph into a new graph that might have a meaning that is relevant to something you're trying to figure out. Trying to understand, trying to represent. Okay, very important idea. Okay, well, another way to transform, there's 4 ways that are covered in your text. I'm only going to talk about 3 of them. And in this course, I really pretty much, for most of the course, am mainly concerned with the 3. Okay, so you have the vertical shift, the horizontal shift, and this. Okay, I won't give this a name just yet. But we want to move the point 2,4 twice as close to the x-axis. Now, there are lots of ways you can move a point twice as close to the x-axis. You can go over here, now you're twice as close, because here you were this far, and you move over this way, and now you're only this far, which is half of this, okay? I'm saying when you move it along the most direct path. So here's the point 2,4. Your most direct path toward the x-axis is this way. So this dotted line gives you the most direct path, and now you want to move along that path twice as close. So we go from the point 2,4 down to a point that's right halfway between this point and the x-axis along a vertical line, because it's a vertical line that gives you the most direct approach to the x-axis. And that puts us here. Maybe I positioned that point well, maybe I didn't, but it's now twice as close. And now, what are the coordinates of the point? Well, we've moved vertically, we haven't moved horizontally, so x won't change. The y value is going to become half as great, because the y value here on the x-axis is 0, so we're moving from y equals 4 halfway to y equals 0. That's at the point where y equals 2. So the point is now 2, 2. So there it is. Okay. Now, another way we could move, and actually this is the 4th transformation. We could move, and of course we could have moved twice as far from the x-axis, or 3 times as far, or 48 times as far. Okay, we would move away from the x-axis, straight away along the dotted line that just continues this. Now, here we illustrate moving further from the axis, but we'll move further from the y-axis. You can move closer to the y-axis, you can move further from the x-axis, but it should be obvious that what I'm saying is makes some sort of sense. Okay, so move 2,4 3 times as far from the y-axis along the most direct path away from the y-axis. We can move 3 times as far along this direction, but that's not the most direct. The most direct is the shortest path. Okay, so we're at the point 2,4. We want to move out to a point along a line that moves straight away from the y-axis in the horizontal direction. So, well, we're this far, so there's an arrow that represents how far we are. Now we can move that far again and that far again. There's where we end up. Okay? So what are the coordinates of this point? Well, we were 2 units from the y-axis because we were x equals 2. And then we moved 2 more, and 2 more puts us 6 units. So there's the point. It's a point 6,2. Now I introduced this because your assignment for, as I said, for next Thursday, it's actually for a week from Tuesday, will be on transformations. We have to be able to transform the basic functions to get into a wider class of functions that are useful for various applications. Okay? This always gives people trouble. So we have this written assignment due Sunday where you're asked to do these kinds of movements, these kinds of motions, okay? And wanted to give you a heads up on this. We want to start this now because transformations is problematic for most people. For some reason, I haven't figured out why, but it is kind of an unnatural thing in the experience of most people. Okay, so there it is.